Welcome, my friends. In this video, I will be giving a brief introduction to vectors. A vector is an object that has both a magnitude and a direction. For example, here is the vector A. The vector A starts at this point and ends at this point. The arrow can be a little bit misleading because some students might think that the vector continues to go on in this direction forever. In reality, the vector starts here and then goes in the upward right direction until it hits this point. The arrow is showing the direction, showing that we go from down here all the way to up here. The magnitude of vector A is just referring to how far vector A travels. So the length of vector A is really the same thing as the magnitude of vector A. The direction of vector A is just saying in which direction are we going. We can measure the direction using an angle, which we will do later. Here is another vector which is twice as large as A, or has twice the magnitude as A. It's in the exact same direction, but the length is twice as long. Here is another vector that is half the length of A, or half the magnitude of A. Once again, the direction is exactly the same, but the magnitude is half of A. A negative vector moves in the opposite direction of the initial vector. For example, here is negative A. Negative A has the exact same magnitude or length as A, except for we go in the opposite direction. So we start where A ends and end where A started. Here is negative 2A. This is the same thing as 2A, except for the direction is reversed. Here is negative 0.5A, so hopefully you're getting the idea. Two vectors can be added or subtracted to form a new vector. For example, consider these two vectors, A and B. A starts at this point and ends over here, and B starts at this point and ends over here. If we were to place B right at the ending point of A, we would have these two vectors. The vector A plus B would be the vector that starts at the same place as A and ends at the same place as B, if B starts right where A ends. So the vector here in purple would be A plus B. Now, the order that you add the vectors together does not have any significance. The vector B plus A would be the same as A plus B. To see why, consider first writing the vector B and then writing the vector A. B plus A would be the vector that starts at where B started and ends at where A ends, if A was to start right where B was to end. This is what the vector would look like. B plus A has the exact same magnitude or length and direction as A plus B, so A plus B is the same as B plus A. Vectors can also be subtracted. So if this is the vector A, and this is the vector negative B, which is the same as positive B except for the direction is reversed, then the vector A minus B would be the vector that starts where vector A started and where negative B ends, if negative B starts right where A ended. The vector in purple would be A minus B. Now, for the subtraction of vectors, the order does matter. So if we had B minus A, that would look something like this. The vector B minus A would be the vector that starts right where B started and ends right where negative A ends, if negative A was to start right where B was to end. This is the vector B minus A, which is actually the same as A minus B, except for the direction is reversed. Let's practice a few problems. Let's say we are given these two vectors, A that goes straight up and B that goes down and to the right. We are asked to construct negative 0.7b starting at the point P. A negative B vector will go up and to the left instead of down and to the right, as B does. So negative 0.7b would look something like this. The direction is reversed and the magnitude is a little bit smaller. Negative 0.7b does not travel quite as far as positive b. How about constructing 1.3a plus 0.8b starting at the point Q? Let's put 1.3a onto point Q. 1.3a goes in the same direction as A, but is a little bit longer. 0.8b will be the same as B, but a little bit shorter, so that will look something like this. 1.3a plus 0.8b will be the vector that starts at point Q and ends at the point where 0.8b ended. That will look something like this. Okay, let's try one more. We are asked to construct negative 0.8a minus 1.5b starting at point R. So now both of our vectors are negative. So for a, instead of going up, we will be going down. And for b, instead of going down and to the right, we will be going up and to the left. The vector negative 0.8a minus 1.5b will look something like this. The component form of a vector is given as x, y, where x describes how far right or left the vector travels, and y describes how far up or down the vector travels. Here is a picture to help explain what this means. Vector A is the vector with the components x, y, where x is the horizontal distance that we are moving to the right, and y is the vertical distance that we are traveling up. Vector A starts at this initial point and ends at this terminal point up here. Of course, if x was negative or y was negative, then the direction could perhaps be different. A negative x would move us to the left, and a negative y would move us down. In this picture, we have created a triangle, and we can designate this angle as theta. The magnitude of vector A is equal to the distance that the vector travels. The magnitude of vector A is represented by A with vertical lines around it. The magnitude of A can be found by taking the square root of x squared plus y squared, where x and y are the horizontal and vertical components of the vector. Now just a few notes here. Don't confuse the magnitude of A with the absolute value of A. The vertical lines are not referring to absolute value. When you have vertical lines around a vector, that is referring to the magnitude of the vector, or how far the vector is traveling. The other thing is, notice that the magnitude of A is actually just being found by the Pythagorean theorem. The magnitude of A is the hypotenuse of this triangle that we have created. We know that we can always find the hypotenuse squared of any right triangle by taking each of the legs, squaring them, and adding them together. A squared plus b squared is equal to c squared, but in this case, we will have x squared plus y squared is equal to the magnitude squared. If we were to take the square root of both sides, we would get that the magnitude of A is equal to the square root of x squared plus y squared. Sometimes we might want to find the direction of the vector, represented by the angle theta. We know that tangent of theta would be equal to y over x, and we would know both y and x. That means inverse tangent of y over x must be equal to theta. The direction of the vector can be found by theta is equal to the inverse tangent of y over x. Let's try a problem. We are asked to find the magnitude and angle theta in degrees of vector A below. We are also asked to round each of our answers to 2 decimal places. Here is the initial point of the vector, which travels up and to the right to this point right here. The horizontal distance is 8 and the vertical distance is 3. We would like to solve for the angle theta as well as the distance that this vector travels, which is the magnitude. The component form of this vector is A equals 8, the horizontal distance, comma 3, the vertical distance. We can find the magnitude of A by taking the square root of x squared plus y squared. X is equal to 8 and y is equal to 3, so this will be the square root of 8 squared plus 3 squared. 8 squared is 64 and 3 squared is 9, so we have the square root of 64 plus 9. 64 plus 9 is the square root of 73. If we'd like a decimal approximation, we can type this into our calculator. We get approximately 8.54. The magnitude of vector A is 8.54. If we'd like to find the angle theta, we can take the inverse tangent of y over x. We will have the inverse tangent of 3 over 8. If we type this into our calculator, we will get approximately 20.56 degrees. The magnitude of this vector is 8.54, and the angle theta is 20.56 degrees. Make sure if you are typing the inverse tangent of 3 over 8 into your calculator that your calculator is set to degrees and not radians. Let's try another problem. We are asked to find the magnitude and angle theta in degrees of vector A below. We are asked to round each answer to 2 decimal places, just like the last problem. Now the distances are all represented by positive numbers here, but if we were to write the component form of the vector, we would have to indicate that the horizontal distance is to the left, which we would represent by a negative 8. So A is equal to negative 8, 7. we can find the magnitude of this vector by taking the square root of x squared plus y squared. We have the square root of negative 8 squared plus 7 squared. This becomes the square root of 64 plus 49. 64 plus 49 is equal to 113. The square root of 113 is equal to about 10.63. The magnitude of this vector is 10.63, so this vector is traveling 10.63 units. To find the angle theta, we can take the inverse tangent of y over x. Now, it's important to note that the angle theta is the interior angle of the triangle created by our vector. It is not the obtuse angle from the positive x-axis all the way to our vector. If we want to solve for the interior angle of the triangle, then we should use the positive versions of the side lengths. We should not use negative 8 for x. So theta will be equal to inverse tangent of 7 over 8. If we plug this into our calculator, we will get approximately 41.19 degrees. Now, if instead of trying to find the interior angle of this triangle, we were trying to find the angle from the positive x-axis all the way to our vector, then things would get slightly more difficult. In that case, we should be indicating our x value as negative. So we would have the inverse tangent of 7 over negative 8. But as you can imagine, this triangle that we have created is in quadrant 2. Inverse tangent will always give you an angle either in quadrant 1 or quadrant 4. In this example, if we had a negative 8 in our inverse tangent, we would be getting the angle in quadrant 4. To find the correct angle from the positive x-axis all the way to our vector, we would actually have to take the output that we got from inverse tangent and add 180 degrees. So as you can see, things would be a little bit more complicated. Thankfully, in this problem, we are only asked for the interior angle of the triangle, so we don't have to worry too much about that. Okay, let's try one final problem. We are asked to calculate the x and y components of the vector a below. Round the components to the nearest hundredth. Here we have a vector that has an initial point right here, and then goes down to the right to have a terminal point right over here. The magnitude of this vector is 36 units, and the direction is 53 degrees down from the positive x-axis. We are trying to find the x and y components. This would be the x component, and this would be the y component. At this stage, we have created a right triangle. We can use the trigonometric functions in order to solve for the missing side lengths. Cosine of 53 degrees is equal to the adjacent side of x divided by the hypotenuse, which would be the 36 unit magnitude. We can multiply both sides by 36 to get 36 cosine of 53 degrees is equal to x. If we plug this into our calculator, we get that x is approximately equal to 21.67. We are traveling 21.67 units to the right of our initial point. We can do the same thing to solve for y. We need the trigonometric function that relates to the opposite side to the hypotenuse, which is sine. Sine of 53 degrees is equal to the opposite side of y divided by the hypotenuse of 36. If we multiply both sides by 36, we get 36 sine of 53 degrees is equal to y. If we plug this into our calculator, we get that y is approximately equal to 28.75. Now, if we were referring to y as the component of a vector, and y represents a movement down rather than a movement up, then y should be negative and not positive. So instead of y equaling 28.75, we can let y equal negative 28.75. This is the correct value that we need. Our vector is moving 21.67 units to the right and 28.75 units down, and we represent that we are moving down with a negative y value. Altogether, the component form of our vector is 21.67, comma, negative 28.75. Alright, my friends, that finishes this video introducing vectors.